Here in 12.7, we've got the idea of a binary file, and the content here is really pretty simple. This is on page, because I've forgotten already, 689. Um, but rather than talk about what we need to do to get something into a file as binary, we would have to cast a character as binary and then read it to a file. So if you think about reading strings of data to a file, that means we would have to take each individual character in a string of data and read those individually as binary and write it to a file. And what I think is more important is not to walk through that. We're going to walk through that in our code sample, and it will go remarkably quickly. But what I want to talk about is why binary files are needed. We have worked entirely with text files this whole while, and when we are working in business with data, it is very, very rarely in the form of a text file. It is usually as binary, and there's a ton of reason for that. Really, it boils down to just 4 or 5 different things, but speed is one of them. We work in characters as human beings, but characters are relatively big, and the storage that they take is relatively big in comparison. But binary is small. Binary is the natural language of, the machine code here. So when we work with binary as a file, it's remarkably quickly. On the other side of that too, it's remarkably compact. So a binary file, even though it contains the same data as a text file would be orders of magnitude smaller. And that's absolutely what we need. Now, files don't have to just be text. A file can be something like an image or a movie, like I'm recording this here as one. If we did this as plain text, whatever your file would be, your image file, your video file would be colossal in comparison. And we want these to take up as little as possible in the way of space, because again, if we can take up less space, we can take up less time. The less time and space we have, the more efficiently everything works. So some kinds of data have to be on the bitwise bytecode level. So things like a Java class file are actually, now I know that this is C++ and that's not what we're talking about here, but it's comparable. So things like a Java class file have to be in machine language, which is bits. It is binary. So source code for a compiler, that's what happens when we would compile out our C++ here. So when you run, Word or something on your desktop, you are interacting with the source code as it was compiled. That is bytecode. That is binary. And the other reason we don't need to care that our files are saved out as binary and a human being is never going to read that is because, don't worry, you ain't never going to read that stuff anyway. When we collect all this data that we're collecting, when we get all of this name, address, phone number data stuff, we can convert rather all of that to text later on. But for a vast majority of the machine time that those files are running and reading and being written to, we're not involved, right? There's no person who's reading through all that. That's why we have computers and code in the first place, to be able to do that for us. So if the files are smaller, if we can run them faster, and if you are never looking at them, or relatively never looking at them anyway, we don't even bother with text. So you would be shocked if we didn't spend just a couple of seconds here in 12.7 you would be shocked when you saw how little in the industry we actually use text. It is far smarter to use a binary file because it is so much smaller. Smaller means faster, faster means cheaper, cheaper means better, well, except, you know, occasionally. But that's the reason for binary files, and it's just kind of a throwaway here in the chapter.